Hello, you are welcome back. All right, so we are going to be looking at the equations of linear motion. All right, so these equations, okay, which of course is a three number, uh, are simply dedicated to solve any question on linear motion. Okay, so these are three equations that is can be used to solve any form of problems in linear motion. I have equation 1, equation 2, and equation 3. So what I will be doing in this video is to actually show you how this equation is derived and of course to show you how they are being applied. Starting with equation 1. So mind you, there are some symbols that I'm going to be using here that might actually be different from the symbol right in your lesson, lecture note, or even in a textbook, but they mean the same. All right. For example, here I have from the first equation, v is equal to u plus at. V is the final velocity. The v represents final velocity. Now, in some book, okay, let me use a different color. Now, in some textbook, all right, I'm very sure that your lecturer possibly use VF, all right, V subscript F as final velocity or V2, all right, but I'm just going to use V4 of final velocity, okay? So whatever symbol that you are very comfortable with. Then if V is final velocity, then U is going to be the initial velocity or speed. All right. Of course, you know what A represents. A is the acceleration. Okay. All right. So delta x, of course, is the change in distance. Delta x is the change in distance, which of course is, giving us final distance s2 minus the initial distance s1. Change in distance. Okay. T, we already know that is time. And I guess that is it. Okay. So that's all. So let's look at the derivation. Let's talk about how this equation are being derived, starting with equation 1 to equation 3. So from equation 1, we derive equation 1 from the definition of acceleration. We know that acceleration is actually change in velocity with respect to time. Velocity changes from initial to final. That's going to be final minus initial divided by time. So if I cross multiply, of course, I'm going to have v minus u multiplied by 1. That's going to give me v minus u equal to 8 multiplied by t. That's going to give me 80. So if I make v the subject, the final velocity the subject, I'm going to have v is equal to u plus 80. So anytime you are being asked to derive the expression for the first equation of linear motion, this is how it is being derived. So this is number 1 derivation. Now number 2 derivation is the fact that we have that velocity, we derive that from velocity. We know that velocity or speed is equal to uh, distance, change in distance all over time. So invariably, change in distance is going to be velocity times time. So a situation where we have the speed changing, all right, we have a variable speed. We have for the entire journey, okay, for the entire journey we can actually, we don't just use speed, we use the average speed because we are looking at the average speed for the entire journey, average of speed. So that means the distance, the average distance or the total distance for the entire journey is going to be equal to the average speed times time. So please take note of that. An average, how do we find the average speed? Since we have the initial and the final, all we just need to do to find the average is going to be, we'll do initial plus final, which is v plus u, then divide by 2. That's how we get the average. Then of course multiply by time. This is delta x. All right, so with what we have now, we can actually open this bracket, delta x is going to be equal to, let's open the bracket. So let me start with this, okay? U multiplied by t, that's going to give me ut, then v multiplied by t, that's going to give me vt. So I'm starting with ut, please. All right, then of course, divided by 2. Okay, or anyhow you want to start with. So we already know from the first equation that v is equal to u plus at. So we'll just put that here. So delta s now is going to be equal to ut plus v already. Let me put that in a bracket. Is equal to u plus at. Okay, then multiply by t. Don't forget all is being divided by 2. Can we proceed now? Yes, we can. So delta s is going to be equal to, open this bracket, ut plus ut again, then plus at square all divided by 2. So this is ut plus ut gives us 2ut plus at square all divided by 2. So if I separate this fraction here, I'm going to have 2ut all over 2. So of course, the same happens here, that is 8 square all over 2. 2 cancels 2. All right, so we're left with just ut, then plus half at square. So that is how it is being derived. So delta x is equal to ut, then plus half of at, then square. So of course, this can also be written like this, since we know that delta s is equal to x, okay, final distance minus initial distance, or x1. Let me use x1 minus x2. Okay, so to make it easier, s2 minus x1. Okay, so it's equal to ut plus half at square. So sometimes don't get confused if in your textbook, if you see something like this, the final distance, or okay, x, if you take this to the other side of the equation, you're gonna have, it's gonna be x1 then plus ut plus half at square. So don't be confused when you see this, because that actually came from the fact that the distance we are looking at is delta x, the change in distance. I hope that is well understood. So that actually gives us the proof or the derivation for the second equation. Then the derivation for the third equation, we are still gonna derive it from this expression right here. This expression, this is where we're going to derive it. Distance, total distance equal to average velocity multiplied by time. Don't forget that expression. Don't always forget the expression that total distance, all right, is going to be equal to the average velocity v plus u all over t, 2, and then multiplied by time. So this time around, we are going to substitute t, the expression for t. From the first equation, we know that v is equal to u plus at. So if I make t the subject, t is going to be equal to v minus u all over a. So that's exactly what I'm going to do. So I'm going to substitute this into this expression. Let's do justice to that. So at the end of the day, this is going to be delta s is going to be equal to, okay, so v plus u all over 2, then multiply by t, which of course is v minus u all over a. Can we work on this? Yes, we can. So look at, I need to actually expand this. Of course, for me to expand this, look at the numerator of this two fraction. Okay, I have the same expression. The only difference is that one is plus while the other one is minus. That is what we refer to as difference of 2 square in mathematics. Once you see such a bracket, to expand that, you're going to use difference of 2 square, method. So to expand that numerator, this is the same as having v square then minus u square, right? Difference of 2 square. Then, okay, 2 multiplied by a, that's going to be 2a. So all I just need to do at this point is to cross multiply. If I cross multiply, I have v square minus u square is equal to 2 delta x. So at this point, I can make v square the subject, take minus u square to the other side. So that's going to be u square plus 2a then delta x. So I hope that is well understood. That is the derivation for the third equation. Now, in most cases, right, you might not be asked to actually derive this equation of motion. What is really important, all right, in examination is the application of these three equations. So I'm going to show you the I'm going to show you the method or some necessary hints that you need to actually take note of when you are applying these particular equations to questions. Now, anytime you read a question on linear motion and you are told that the object starts from rest, and of course every moving object should always start from rest. Anytime an object starts from rest, from rest, starting from a place of no velocity, that simply means that the initial velocity is equal to 0. So definitely in that particular questions, you don't need the initial velocity because it's already 0. Now, if an object is already moving with a velocity, all right, then it actually comes to rest. It comes to a stop. At stopping point, the final velocity is equal to 0. Don't forget this. At that point, for the object to actually come to a stop, it will decelerate. All right, so it will actually decelerate. So it will decelerate, which will give it a negative acceleration. So invariably, in that case, we can say that deceleration is going to be equal to minus acceleration. So there's going to be acceleration with a negative sign. So whatever we have as acceleration, we just attach negative sign to it. So that simply means that in such a case now, when you for such situation where we know that the object is slowing down, right, which of course will eventually bring it to a stop, where the final velocity is equal to 0. So we could actually conclude that acceleration for each of the three equations is going to be negative, is minus. Why? Because it is decelerating, the object is reducing its speed. So the three equations now will actually change. So for the first equation, we have v is equal to u. Okay, instead of plus 80, I'm going to have minus 80. Don't forget. Okay, instead of having plus 80 for the first equation, I'm going to have minus 80. V is equal to u, then minus 80. Don't forget that. For the second, okay, we'll have delta x. Delta x is equal to ut. Instead of plus half 80 square, that's going to be minus half 80 square. All right. Then the last but not the least, v square is going to be equal to u square, then minus 2a delta x because of the deceleration. I hope that is well understood. So now, in solving these questions, okay, using solving questions on linear motion using this formula, there's another, there's a very good and of course important approach to such questions because those questions are usually in a word problem, all right? So now, you're not going to use these three equations at once. You can only use one at a time. You can only use one at a time to solve the questions. So the question is, what actually determines the equation of motion you're going to choose? So whenever you're reading the question, please, the very first step you're going to do is to write the parameters. Write parameters. Write the parameters, including that particular parameter that you are being asked to look for. Then with the parameters now, you can now choose the right equation. Okay, choose the right equation, the equation that actually captures the parameters that you've written. And once you do that, you are good to go. All right, so we're going to look at the application of this equation of motion in the next video. So see you in the next video. Thank you very much.